Hey everyone, Mr. Vargas here once again, helping out Integrated Math 3, IG Math 3, Homework 4.3, Polynomial Functions. I'm just going to do a few example problems and then let you guys get on your way with the assignment. Let's start out with number 3. Okay, number 3, we've got negative 5x to the 5th power plus 3x to the 3rd power minus 8. And we are just simply asked what is the degree of the polynomial and the leading coefficient. So this is already in descending order, meaning my exponents for my variables, they go down as we go to the right. So this is considered descending order. Since this guy right here is the top dog, he's got the highest degree, we would say that this is a degree 5 polynomial, and its leading coefficient is just that number in front, so that would just be negative 5. Alright, that's it for that one. Let's check out number 6 really quickly. Number 6, we've got 2r minus r squared plus 1 over r squared. Okay, so you might be tempted to rearrange this into descending order and figure out which term has the highest exponent or the highest degree. But here we actually run into an issue where we have 1 over r squared, which, as we know, is the same as this polynomial, well, as this item. That would be plus r to the negative 2. And unfortunately, in order to be a polynomial, we cannot have any negative exponents. The exponent of this variable is less than 0, so we would not consider this a polynomial in one variable. Alright, moving on. Let's go ahead and check out number 7 really quickly. So number 7, we have this function p of x is equal to 4 minus 3x, and we're asked to evaluate it at p of negative 1 and p of 2. So we've got to do two separate calculations here. Basically what this means is wherever I see an x as my input, instead of x, I'm going to input negative 1 into my rule, my function rule. So this would just look like this, 4 minus 3 times negative 1, and that just would become 7. Negative times a negative makes a positive, so basically you have 4 plus 3, and that's where I got 7 from. Okay, and then when I plug in 2, be 4 minus 3 times 2, and that just becomes 4 minus 6, which leads to negative 2. Okay, those ones are pretty straightforward. You might be a little stuck on problem number 12, so let's check out that one. So 12, I am asked to find the value of r evaluated at 2a. Okay, so first you got to find the function r, and they give that to us. It's just r of x is equal to 1 plus 3x. Now, since we're trying to find this function's value, the function name is r, we're trying to find the value of r at the input 2a. All I'm going to do is wherever I see an x, I'm going to replace it with 2a. So, in my equation here, r of 2a is just equal to 1, which comes from here, plus 3 times, not x, because we're not evaluating it at x, we're evaluating at 2a. So I'll just put in 2a. Simplify that and you are done, so it's just 1 plus 6a. So r evaluated at 2a is equal to 1 plus 6a. Easy. Okay. I can do number 14 really quickly. Okay, number 14, we need to find r evaluated at x plus 2. Alright, I know that r of x is equal to 1 plus 3x based on the problem's information. So now once again, instead of just replacing x in my rule, I'm going to replace x plus 2. I'm going to input x plus 2 in my rule. So r evaluated at x plus 2 is equal to 1 plus 3 times, not x plus 2. Simplify that out, you get 1 plus distributive property 3x plus 6. So that just means that r of x plus 2 is equal to 3x plus 7 when I combine like terms. Nice. Let's move on. We're going to talk about number 16 really quickly. Okay, number 16. I'm just going to draw a rough sketch of what 16 looks like. Here's my xy coordinate plane, and I've got a function that looks kind of like this. I'm not even really worried about the numbers right now. Alright, got this thing happening. Okay, this is a polynomial, and we are asked to describe the end behavior first. So the end behavior just basically means what is happening as we approach negative infinity in the left direction, and what happens as we approach positive infinity in the positive x direction, okay, or the right direction. So let's talk about this end first, this left hand tail end. And as x, if you start at the origin, as x goes towards negative infinity to the left, what's happening to the value of the function? You might also want to think of this as, instead of y, think of this as your f of x axis. So I would just write this as x approaches negative infinity to the left. So as we go this way with our graph, what happens to f of x? Well, f of x is going down towards negative infinity in the f of x direction. So as x approaches negative infinity, f of x also approaches negative infinity. Quick little reminder, this symbol, this arrow symbol, just means approaches or goes towards. So as x goes towards negative infinity, f of x also goes towards negative infinity. Now let's talk about the right-hand behavior, what's going on as we go to the right. And the way that I could describe that is as x approaches positive infinity, since we're going this way towards positive infinity, f of x approaches what's happening with our function here. It's still going down this way, so it's going towards negative infinity in the f of x direction. So there you go. That would be your end behavior. All right, now determine whether it represents an odd degree or even degree function. Now if your end behavior, so my left hand behavior and my right hand behavior, if they approach the same type of infinity, negative or positive, then you are going to have what is called an even function. So since this function right here approaches negative infinity as you go to the left and negative infinity as you go to the right, we would say that the function, I'll write it in red, the above function is even. Okay. Good, we've got that figured out. Now the next question just becomes, how many real zeros are there? And that's just the amount of times that we cross the x-axis with our function. So our x-intercepts or our zeros or our real solutions are here, here, and here. So we would say that the function has 4 real roots, or 4 real zeros, or 4 real solutions. Lots of ways to talk about that. So the function has 4 real roots. Another word for root is a solution. Or you might also see the word 0. Okay, so the above function has 4 real roots, solutions, or zeros. Any of these words are acceptable. I forgot my S there. Okay, so that's it for today. I hope you guys do well in the rest of the assignment. Let me know if you need help. All right, thanks.